So today's lecture will cover programming graphical user interfaces in Java. And it's important to note that what we are going through today will not be necessarily enough for you to be able to build fully interactive Go applications, but will provide enough information so you can at least begin and make interesting stuff. There are some advanced things that we won't be able to cover in the time given, but we'll give you enough so you can go on your own and develop on that. All right? So generally, graphical applications will usually have a graphical user interface that, image and some variation of colors and so on. So far, what we've been doing is building applications that use text-based interactions with the user. And in some instances, we've done some command line type prompts for the user to provide information, and then some action is taken. We have also built text-based menu, but now we're going to transition a little bit using some Java component to build what we call graphical user interface. So if we were to take the example that we see here, right, you will note that there's a nice dialog box here, right? Oops, I've gone too far, right? That is showing you something that looks a little bit more pleasant than using text only. Now, most modern computers provide a graphical user interface that allow the user to perform certain tasks by interacting with graphical forms. And in particular, this makes particular use of the mouse and other pointing devices. So for example, this dialog box is something that you would see when you're trying to open a file or you're trying to save a file, for example, right? You type the information in some box, you click some button and make some choice, and then thereafter it will carry out those actions. Now today we're going to look at containers and components first, then we're going to look at interactive forms, and I'm going to make a few comments on layout managers and borders. The lecture is not going to be so focused on layout managers, because the next time when we meet, we're going to look a little bit more on layout managers and borders. But I'll give you just enough so you'll be able to begin using layout manager at least in your own spare time and possibly for your project. All right? So then, does this screen look familiar? No, you've never seen an application looking like this?
Yes.
Oh, you have? Good. All right. So if we were to break this down, all right, so obviously this is a Java generated graphical user interface. And if we were to break this down, everything on this screen has a name, okay? We can identify what we would use that is already built into Java to build this, okay? So first of all, we notice that we have a word here, yes? First name, yes? Now what we use to make this text appear here is called a label, all right? This box here is a text field. Likewise, this box, this, and this. These are also labels, yes? Now, here we have a list with item 1, item 2, and we allow the user to be able to click this down arrow to see the options that they can choose from. Here we have another text box or text field, sorry. Then these are also labels, right? Then here we have a radio button, and over here we have regular buttons, okay? And more buttons, right? This is also a list box, right? A variation of our list here, okay? So then, oh, I didn't mention that the outer part here, right, where this looks like our windows, right, this blue here with the minus the square and the X is what we call the frame, Okay, and that actually is controlled by the operating system. So when you have an operating system and you set up your theme, that outer piece is that is a frame is always going to take on the scheme that you're utilizing from your operating system. All right? Any questions so far?
No.
Everybody happy? Okay. All right. So here we show you what is called a panel with a border. So we're going to be using panels extensively today. So a panel can exist without a border, but just for the sake of you seeing where the panel is, right, we have put in this border here, right, where you see that blue line, right? Now, if you look below, all of the information below here is actually in another panel, but this panel has no border. All of a sudden, we realize that we can use panels to segment our components within our application or within our view, right? Even invisibly. So you can have a background arrangement, right, that is set by your panel and the dimensions of your panel to make sure that your interface looks good, right? And you can have it with a border or without a border. And that's an example there. Okay, so in general, a GUI component is an object that represents a screen element such as a button or a text field. So I'll refer as we go through the lecture to components. Now in general for Java, the AWT and Swing packages are primarily what we will be using to do GUI programming. Now AWT, of course, was the original Java GUI package, but the Swing package provides additional and more versatile components. Now, we're going to use both of them because in general, both of them are needed to build Java-based GUI programs. Now, a GUI container is a component that is used to hold and organize other components. We're going to look at two today, which is a frame that is used to display a GUI-based Java application, as I just gave an example. A frame is displayed as a separate window with a title bar, so that's where the title of the application is, and it can be repositioned and resized on the screen as needed. A panel is a container that cannot be displayed on its own, but is used to organize other components. All right, so a panel will not show up anything. Really, it's just a space that you have defined to put other things. So, in general, also a panel must be added to another container to be displayed, right? And usually, it is added to a frame or another panel. Now, a GUI container can be classified as either lightweight or heavyweight. I gave you an example of the heavyweight earlier. When we say it's managed by the underlying operating system and the themes there, lightweight containers are managed by the Java program itself. And in a few cases, the distinction may become important, and we'll see that a little bit later. All right, in general, a graphical user interface is a set of containers with other components, and here are some examples of the components. We have a frame, we have JPanel, JLabel, text field, button, text area, radio button, and checkbox. There are many, many others, but those are the ones that we're going to start off with. And then I'm sure you will go and explore and learn of the others. So let's take each of them by themselves and talk a little bit about them, and then we're going to put them together and show you how they can build you a fairly simple GUI. Now, a label is a component that displays a line of text, and that's all it is. It does nothing special. Labels are usually used to display information or identify other components in the interface. It's like a description that you're going to put beside a text box. Generally, that's what we use it for, or some radio button or something like that, right? It's not interactive, but the frame can be repositioned and resized, all right? Now, here's an example of some Java code that would allow us to create a label. Now, of course, you realize here, many of the things that we've been doing so far. But notice we include the swing and the AWT packages, right? So that it can allow us to do what we want to do, right? Here, inside our main, we create a frame, and we give that frame a name called authority, all right? Then we usually have a few lines of code that are always associated with a frame, okay? One of them is exit on close, which means that the program will exit once the frame has been closed, all right? Now here we're creating a new JPanel, and we're setting the background color, right? So the JPanel is called primary, and we're setting primary's black background color to yellow, and we're setting the dimensions to 250/75, all right? Now, to that, we are going to be adding label 1 and label 2. So we create 2 new instances of JLabel and pass a text in there that instantiates it and set the label to that text. Notice here that we're now adding label 1 and label 2 to the panel. Okay? Yes? And then we are now adding the panel to the content area of the frame. Now these 2 lines, frame.pack and frame.setVisible, you're always going to have to use that in order for your application to come to life or to show, all right? So those 2 statements, generally you always need them, all right, when you're using frames, all right? Now if we run that, what we will get is the example here. Yes? Everybody with me? Any questions? Now, of course, you would have seen that this frame, the layout looks a little different, yes? Of course, this was run on a different type of operating system, and so you realize that the frame takes on the theme that is currently being used on that system. Yes, you realize you didn't see the Windows buttons in the typical top right-hand corner, for example, yes?
Yep.
Good. Now, if you were to resize the panel or the frame, then the window is going to, well, it's going to automatically move around the text. So the first image here is showing you how it comes up based on the preferred size that we set earlier. And then if I wanted to stretch it, and it comes, and this is now the new size, notice the text that was in line 2, which was up here, is now in line 1, right? So now once you resize the panel with the frame, the labels are repositioned, okay? Now this is because there is a particular layout that is automatically applied if we don't set the layout, okay? And we're gonna talk a little bit about layouts a little later. All right, some basic. So the example has demonstrated several key concepts of Java GUI programming, right? Every GUI component has methods that can be invoked to set or query its state. Okay, so I can change the state of a component, or I can query what state it's in, and so on. So for example, the preferred size of a panel can be set by invoking the setPreferredSize method. The documentation for each of these components are detailed, gives a detailed list of these and what can be invoked on it, and there's a lot of reading to do in the API. Okay. When using a JFrame object, components are added to its content pane. I made mention of that using frame.contentPage, where frame is the name of the JFrame, and then you add the panel to it, or you can create a container and then add the content frame to that, right? Any questions? The container is a swing class, yes? Any questions?
Nope, not yet.
All right, 1 second. Please note that the class container is a swing class, right? As I mentioned earlier, you're gonna always primarily need the swing and the AWT packages, except in specific cases, a few of which you might see a little later. I talked about the color already. You can set the background to color as you see here. And set background is defined for JFrame and other containers. So many other containers can be changed in terms of their colors, right? And then of course you have to pay attention to the colors that are available, right? Notice we use the color.yellow, which suggests that color is a static class that you can invoke and get back a particular variation of the mixing that gives you yellow. All right. Set preferred size sets what size the object will be when it is initially positioned. Of course, some objects are resizable, right? But you can also set the object that it's not resizable, right? So if you want to change, of course, you might have some applications where the main window is a particular size and you cannot change that size because when the programmers were developing, they decided that it is not going to be in the best interest of what they want to display on the application screen for it to be any larger or any smaller. And so they fixed that size, and so they would disable your ability or remove your ability to resize. So that also can be done. And then, of course, you will realize that panels can exist almost anywhere, and you can nest a panel inside a panel for layout purposes. All right, so you can create a segment that is a panel, right? So basically, you could have a panel like this, and then you have another panel here because you want something to exist over here. Then you have another panel there, and then you could have one down here. Yes, and you can put them all over the place, right? So there you realize we have an outer panel and inner panels, and even in the inner panel you could also have another panel in here and another panel, and that's what we talk about when we say nested. Okay. Containers that can contain other components make up the containment hierarchy of a graphical user interface, and this hierarchy can be as intricate as you want it to be, right? And here's an example that we're going to talk about that nests some panels. So we create a class, of course, these you would have seen already, called nested panels, and that class, first, we create a JFrame and we set up as usual. So now we created a panel called subpanel 1. We set the preferred size and the color to green, and we create a label and we add that label to the subpanel 1. So basically in subpanel 1 we should have a label that has the word ONE. Then we create another subpanel 2, and we set the dimensions and the color to be red, and we set the label that we created to 2, and then we add label 2 to that, okay? Then we create our primary panel, right? Which now its background is going to be blue, and now we add subpanel 1 and subpanel 2 to our primary panel here, right? And then now we take that primary panel and put it on the content area of the frame, pack and make it visible. So notice we're building, and then once we're finished building, then we put on, yes? So the last thing we end up doing is putting everything that we have now accumulated onto the content area of the frame. Okay? Everybody with me so far? Because once the frame is packed, you want to make sure that you have everything there, or else you have to repack it, yes? And this is what it looks like. Well, the first one is what it looks like. Yes? Now, if you try to resize and these two can no longer hold, 1 and 2 can no longer hold in the space, right? Then what it will do is try to reorganize the panels. So now they are being shown vertically rather than horizontally. Yes? Any questions on containers and components?
No, sir. No.
Oh, good. All right. So then we can talk a little bit about GUI forms. And here is where it gets interesting, because what we've talked about so far are just showing things, right? We've just only talked about a text being displayed or a panel with a color, and there is no interactivity there. So you can't get an application out of that. So now we need to find out, how do we make these things do stuff that's realistic, all right? So the forms in the previous example simply displayed panels and labels, and we need to use the Swing library and its many components to make our interface interactive. Now, in Java, there are at least 3 kinds of objects. There are components, events, and listeners. And I'm sure you can guess what those are. All right? We talked about components already. Yes? Events are things that occur. And listeners, right, are like some people we know. Right? They will pick up anything that has happened and use it. Okay? Now, we previously discussed components, so that's out. We talked about frames already and panels, right? There are applets and dialog boxes that we will come to in a little while. Now, first of all, let us talk a little bit about events. So an event is an object that represents some activity to which we want to respond. So something happened, and we need to be able to do something because that thing happened. So for example, the mouse might have moved, somebody may have clicked something, the keyboard may have been pressed, or the screen may have been up for a particular amount of time and that time has expired. And now we need to do something in our application. Now the Java API contains several classes that represent typical events, right? Such as a graphical button being clicked, which fires an event. And in order to make use of this event, we have to set up what is called a listener object to respond to an event when it occurs. It's kind of like when we were doing exceptions. And if this exception happens, then we will carry out some action that is associated with that particular exception. Okay? So we can design listener objects to take whatever actions might be appropriate when the event occurs. So in general, there are components in Java that can generate an event. Okay? Everybody with me still?
Yes, sir.
Right. So components can generate events in Java. Right? An event can be attached to a listener. So the listener will respond once that event is generated. So when the event occurs, the component calls the appropriate method of the listener and pass that object that describes the event to it. Now, to create a Java program that uses graphical user interface in general, we must instantiate and set up the necessary components, implement listener classes for any events we care about, and establish a relationship between listeners, components, and the components that generate corresponding events. So we're going to explore some new components. And here's one, a button. So a push button is a component that allows the user to initiate an action by pressing a graphical button using the mouse. The push button is defined by the JButton class, right? And it generates, what it generates?
An action event.
Good. So it generates an action event. I notice I put that in red because that becomes important. You have to know what kind of event is generated by the different things you can put in your interface, your different components. So an action event is generated by a JButton. Now the push counter example displays a push button that increments a counter each time it is pushed. So basically when this button is pushed, right, what should happen is that the count is gonna go up. Yes, everybody with me? So here's what the code looks like. We're now importing the specific event package from the AWT, right? Now, that is gonna allow us to process events. Now we're creating a push counter panel which extends a JPanel. And remember what that means, right? It's an inheritance relationship. So basically everything in J panel is going to be inherited in push panel, right? And then everything here are additions to J panel that we want to do. Everybody sees that, right? With inheritance, we're taking everything from the class that we extend and we're adding things to it. Everybody see that? So now, this is a panel which will also have an integer, a J button, and a J label. Okay? So our constructor, right, push counter panel, right, which is for our class, right, automatically sets our counter to 0, and it sets J button, which is push, called push, to a new J button, and it passes in the label that the button is going to take on, which is push me, based on what you saw here, right? So it sets up that. Now, we're going to add to push. What is push? Push is our button, right? So we're adding to push an action listener. And that action listener takes an event called button listener. Okay? Everybody with me so far? So we have just added an action listener which takes in a button listener event. Now, we set the label to pushes plus count, which this plus means it's concatenating the value of count to pushes, which is what you see here. So that's what that does, okay? Which is a text label, which is different from the button, right? Now, what we have done is to now add push and add label to the panel. Notice because we're inheriting, right, the J panel, and J panel comes with the add, we can just use it because it's in the parent class there. So inside the constructor, we can just do add, and we add push and the label. And we set the preferred size and the background color. Now notice that we create a class inside the current class, which is called an inner class. Now this class is called button listener, and it implements the action listener interface. Notice around here, the action listener takes in a button listener. So now we are creating the class called button listener, but it's inside of our current class push counter panel. So it implements action listener, and the action listener interface basically has one method that you must implement, the action performed. Now this action performed method takes in an action event. Okay? Now this action event called event, right, is now accessible in the body of this action performer. And what we do is to now inside here add one to the count and set the text of label to pushes and the value of count. So obviously if count was 0, count now becomes 1, and then I reset the text of label as we had up here, right, to show the word pushes plus the value of count. So every time you push, it will generate this action. It's going to add one to count and then show the value of count beside pushes. So whenever the event that is attached to the button, which is button listener, is triggered, then action performed is actually executed. Everybody see the link? So we add an action listener to push, which is a J button. That action listener takes in a button listener. So when push generates an event, the button listener is instantiated, and it runs the action performed, right? Which does something to change the count and change the text that is on the panel. Okay? Now, so the point here is that the button listener class is a listener for the action event generated by the button. It is implemented as an inner class, I told you that. And it facilitates the communication between the listener and the GUI components, right? Note that inner classes should only be used in situations where there is an intimate relationship between the two classes, and the inner class is not needed in any other context. So in this case, the only time I need the button listener is associated with the button called push. And so there's an intimate relationship between this class and the push counter panel class, and so that's why we create an inner class here. There's nowhere else that we're going to use this particular class called button listener. All right. Again, the only method in the action listener interface is the action performed method, and so the Java class library contains many interfaces for many different types of events, but in this case we're using an action listener. Okay. The push counter panel constructor instantiates the button listener, establishes the relationship between that and the add action listener. Sorry, it establishes the relationship between the button and the listener by the call to add action listener, which I showed you earlier on. So when the user presses the button component creates an action event object that calls the action perform method of the listener, and it increments the count and modifies the text. And of course, we can now write a Java, a kind of Java class, which is going to now use a frame. We create a frame here, right? And of course, we set up the default close operation, and then we just add a new push counter panel to the content area of the frame, pack it, and make it visible, and our application can now work. Yes? And of course, as you push, it's going to generate an event which increments the counter, so you will see the value beside pushes increase. Quick check. So which object in the push counter example generates the event? No answer?
The button.
The J button, very good. What did it do then when the event was generated?
That you created.
It incremented it and?
And then this update.
So the button component generated the event, and it called the action perform method of the listener object that had been registered. And remember now, in your action, in your method, you can actually do anything you want to do. We're just tying it together. So in your action performed method, you can write any code inside of here to make sure that whatever you want to get done, right, based on the event that has been generated, gets done when that event is actually generated. Okay. Now, text fields is another type of component, and they allow the user to kind of enter a line of text. If the cursor is in the text field object generates an action when the enter key is pressed, right? Now, otherwise, you probably want to have a button that may be used to trigger some action. So, for example, let's say you have several text fields that you might want to collect some data from the user. Let's say you want to collect a username and a password, right? When the user puts the cursor inside the text field and press enter, that generates an event. But again, you probably want to make sure that it's not each text field that is generating an event. You might want a button that says submit, and then when the user presses that submit, you want to check the text fields to see if they were filled out properly, and then you proceed with some action. Yes? So it's two separate things. Text fields can generate an event on their own if the user put the cursor inside the text field. When they press enter, it generates an event. But also, you can use a button to generate the event, and then you can check through your text fields to see if things are what they're supposed to be. Right? So in and of themselves, they can generate an event. That's the important point. And so here we go. We're going to look at an example with the conversion of Celsius to Fahrenheit. All right? In this case, we create a class called Fahrenheit, which has a frame. And this is going to be the title of the frame as usual. And you have seen all of this. Now notice in Fahrenheit, we create a panel. And we're going to call that new Fahrenheit panel. And then we're going to be, which is a new Fahrenheit panel, sorry. And then we're going to add that panel to our content pane. All right? So this is basically our Java class out of the way. So now let us look at how we implemented the Fahrenheit panel. All right. Well, of course, when you put in the value inside of the text field here and you press enter, it will generate an event, which is going to now be what we're going to use to trigger the calculation that is going to translate the temperature from Fahrenheit to Celsius. Okay. So, of course, our usual packages are imported. All right. And notice our Fahrenheit extends JPanel, and I explained what that meant. Now, on our Fahrenheit panel, we're going to need a J label, input label, output label, result label, JText field, which is called Fahrenheit. All right. Sorry. We're going to have a J label called input, output, and result. And then we're going to have a JText field called Fahrenheit. My bad. All right. Now, our constructor is going to set up our different labels. Right. The first one, enter Fahrenheit amount, temperature in Celsius, and then our final label is going to be 3 dashes, which means that we don't have any result as yet. Now, here we create a new JText field of size 5, which means that we can take up to 5 digits, and that is our Fahrenheit value. Okay. Now we are adding to Fahrenheit, which is our JText field that we just created here, an action listener, and we're going to call that temp listener. So notice we can call our action listener anything. Okay. So the temp listener is going to be the class that is associated with Fahrenheit as the action to perform when that event is triggered. Remember I said a text field can trigger an event, yes, if you press the enter. So then, we can add our input label of Fahrenheit and so on, right? Set the preference size on the background. And now we move to our temp listener, which again implements action listener. Now, action listener interface has an action performed, and then it takes in an action event. And inside here, what we do is to get the text, right, from Fahrenheit. I remember what Fahrenheit was. Fahrenheit is a JText field. So there's a method associated with the JText field that allows us to get the text. And we put that into a string called text. Then we parse that text and change it to an integer. Yes? And then we now do the calculation that will convert the Fahrenheit, right, minus 32 times 5/9 to give you the Celsius. And the last thing we do here is for the result label, we set that text to whatever we got back from this calculation and put in Celsius temp. Yes? Notice we use the integer.toString to convert whatever value is in Celsius temp to a string so that it can be showed in the result label. Yes? Any questions? Everybody happy? Good. So like the push counter example, the goal is set set up in a separate panel class. The temp listener inner class defines the listener for the action. And if you look inside of the temp listener, you will realize that we are doing a number of things. Right? Again, as I said, in your action perform, you can put any code that you want to carry out that is associated with a particular event there. All right. I asked you what you noticed, but maybe you weren't seeing what I was showing you here. This line of code is likely to generate an exception if the user put in a text value that cannot be converted to an integer. Let's say they put in ABC123. Then of course it's going to generate an exception. We didn't write in the code there to handle the exception that might occur because we didn't want to crowd the slide with too much code. But of course you'd be expected to do that, all right, in your project and so on. All right, so then when the user types a temperature and presses enter, the text field generates an action event and calls the action perform method of the listener. And the action perform method computes a conversion and updates. Now, there are some cases where you have more than one things on a panel that can generate an event. And you need to be able to figure out which of the items actually generated that event. Okay? And to do that, there's a special method called getSource, right, that you can use when an event is passed to a listener to determine where did that event come from. And so here's an example. We have a class called left-right, which is going to now set up our frame and add what we call a left-right panel, which we're going to talk about now. Okay. Now, simply put, we have two buttons, left and right, and we want to be able to tell which of these generated a particular event. And essentially what is going to happen, if you press the left button, then the text here should change to left. If you press the right button, then the text here should change to right. So that we can show that, yes, we know where the event is coming from, right? And it's something you are expected to play around with. Of course, let me stop to interject and note that all the code that we're going through today, plus some additional code, which will expose you to some other things that we might not have enough time to go through in terms of layouts, different variations of GUI, are posted online in a zip archive, and you can go online, pull that down, run it with a series of demos and examples, right? I also suggest that you play around by making modifications to the code to see the changes that occur when you modify different parts of the code, right? So our left-right panel, right, of course extends JPanel, because we're using a JPanel, but we're adding to it two J buttons, one called left, one called right, a label called label, and a JPanel called button panel. All right, that's where we're gonna situate the button. So our constructor sets up left and right to some text and creates a new button listener, right, called listener. I want you to pay attention to the variations here, right? Now, we add an action listener to left button and a action listener to right button. Notice we're using the same listener object here. We're adding the same listener to left and right. Instead of creating two different listeners like listener 1, listener 2, right? We use the same listener. Yes? Then we of course set up our label and our panel and the dimensions and so on, which you have seen before. Last thing we do is to add our label and our button panel, right? So this is where we give the example of a nested panel, because our button panel is going to be inside our left-right panel. Everybody with me on that? So then, our button listener class, which implements action listener, right? It has its single method called action performed. Now an action event is going to be generated, and we're going to call that event when you either push the left button or the right button, because both of them have an action listener, right, that is attached to them. And that action listener is a button listener. Now, remember we created button listener, right? And that is going to be listening via the object listener, which is an instance of button listener. So then, inside button listener here, when an event is passed to our action performed, we can now say event, which is the name of the action event that is passed in here, dot get source. And now we can check if that source is left, right? And if it is left, then we set the text of label to be left. Otherwise, we set the text of label to be right, which is how our label will actually change. When you press left, it will set the text here to left. And if you press right, it will set the text here to right. Any questions?
No.
Everybody happy? All right.
Actually, can you go back to the slide?
Say that again?
Can you just go back to the slide and just
Go back here.
just want to see the
So this is going to be very applicable when, for example, you create a layout that may have a cancel button, a submit button, a reset button, and so on, where you might add the same button listener to them and just write the code inside your action perform to say, okay, if the person press cancel, then you clear all that they have put in before. If they press submit, you might need to connect to a database and write out the data to the database, right? And if they click reset, then maybe you just change certain fields to their default and so on, right? This is applicable in those cases. Now, of course, you could create several listener classes. You could create a button listener 1 and a button listener 2, right? And inside of each of them, you have the action perform method that you write the code that is associated with each one. But you can also do it this way. And when you do it this way, then you will have to now make sure you get which button or which component generated the particular event, because each event or each component that generates the event will trigger or should trigger a different set of actions. And we capture that set of action by using this if statement here that says if the event is left, then we do this. If it's not, then we do this. All right? And this is a very simple example, but it shows you how we distinguish between where the event is coming from and the actions associated depending on that. All right, so then, layout managers and borders. I'm just going to make some quick comments on layout managers and borders, and then we talk a little bit about some guidelines. All right, so a GUI container lays out its component according to some definite rule, and you would have noticed in the examples demonstrated that components realign when the frame is resized. And of course, this is because there is a layout manager at work, right? Although we didn't define one. Now, I told you that one is assumed if you don't specifically state it. Now, a layout manager is an object that determines the way the components are arranged on a container. And many of them are predefined. We have the flow layout, the border layout, the card layout, grid, and grid bag layout. Now, the flow layout is what is assumed if you don't specify a layout. Now, the next time in our next lecture, lecture 11, we're going to talk a lot more about layout. So today is just a kind of introduction so you can begin to see how these work. All right. All of these belong to AWT, and then we have the box and overlay, which are defined in Suite. Okay. Now, every container has a default layout manager. And I just told you which one comes with our frame that we're using. Each layout manager has its own particular rules. Some pay attention to the component's preferred size or alignment, while others don't. Anything you do, it accepts and works with. A layout manager attempts to adjust the layout as components are added. Right? And of course, we can set the layout of a panel by just using the set layout and then instantiate an object of the layout that you want to use, like we have it here. So if we have a panel called JPanel, we can say panel dot, if we have a JPanel called panel, we can say panel.setLayout, and we pass into that the layout that we want to use. And of course, we're passing a constructor, so these names would hold, of course. All right. Now, there's a lot of code that have been posted online, the layout them on the intro panel, which actually gives you an example of how each of the layouts actually work, right? I am going to ask you to go and download the zip file and run the code and see. What it does, it shows you how each of the layouts actually work and looks, and you can resize and see how those are can be applied. All right. I told you already the flow layout puts as many components as possible in a row, and the flow layout is the default layout manager if no layout is set. It is assumed. All right. Border layout defines 5 areas into which components can be added, and I'm sure you probably would have seen an application that looks something like this, where there's a top kind of area where you put the major description of what is happening on or the major title. You have a west where you might have the menus that you can click on. You have a center where whatever data you're working on or whatever feature you're accessing is now visible. And maybe, you know, the east and the south might have some intermediary information or some buttons that will allow you to further manipulate what is in the center. You've seen this before, yes? A lot of applications actually use this. And the reason why is that it comes predefined, right? And so you can just put things in the different parts of the layout, right? You can just put things to west to center instead of having to build a panel, right? And then nest these different panels with their various sizes inside there. It saves you a lot of work if you just use this particular layout. And so this is probably one of the more popular ones. All right. The grid layout presents a container components in a rectangular grid of rows. One component is placed in each cell of the grid, and cells have the same size. And the grid panel code is available for you to play around with. And then you have the box layout, which organizes components horizontally in one row or vertically in one column, like a stack on top of one another or going right across. All right. And of course, you can combine layouts. Now, box layout has invisible components that can be used to take up the space in between the different things that you're putting together on your panel. And so you can create a ridge area, or you can glue things together, and so on and so forth. As I said, we'll spend a little bit more time talking about layouts the next time we meet. Now, what we can also do is to use borders to enhance the different panels or layouts. We can put a border around almost any container or panel, but it's not absolutely necessary. We can use it for color purposes or to distinguish or to allow our user to see differences in segments of our application. So you can use a line border, an etched border, or an empty border, bevel or titled border, or even a matte border. All right. You can combine different borders together, you know, to make your program look more interesting. All right. And just to conclude, please be reminded that when we're building applications, we're oftentimes not building it for ourselves. Applications are built for some user other than us, and we have to keep that in mind. Although you will be doing further courses in user interface design and the like, I paused to make that comment because the common challenge that is usually expressed, and users tend to agree that if the way they are interacting with the program is ineffective, their perception is that the program itself is ineffective. So the user interface is the program. So you write a program that is excellent in terms of how it calculates and presents values. It is technically very good, but the interface is not good. The user will think that it's not a good program. It is like if the interface doesn't allow them to use the program, then they can't see the usefulness of it. It therefore means that the GUI designer should know his user, try to arrange the components to make sure that user errors are minimized and that user abilities are maximized, and it's always suggested to be consistent and, if necessary, simple. So knowing your user actually implies an understanding of their needs, what are their common activities, and their level of expertise within the problem domain, right? And then many users also differ from others in terms of how they work, right? And as I mentioned before, to the user, the interface is the program. So if the interface is no good, they conclude the program is no good. You want to also design to make sure that wherever possible, you're minimizing the user mistakes. So we want to choose the best components for each task. And a simple example is that if you know that, for example, the user need to put in country, for example. The list of countries is a finite list. The variations are not that many. Instead of giving them an open text field, right? Give them a list box with all the countries so that they can select. In that case, you're sure that the user will not make the mistake of typing in a country that doesn't exist. All right? Now, in the case where we cannot, curtail the input and help the user any further, appropriate messages should be provided when something is not being done properly or there's an error. All right? It is also suggested that where possible, you give the user the option of doing things in multiple ways. Because there are some users who prefer to use their keyboard, some prefer to use the mouse. Some users prefer a walkthrough wizard, while some people prefer to use shortcuts and be able to modify and vary in what they want to put in as they try to do their task. And so, if possible, remember it's not always possible. If possible, you want to give the user multiple ways. By now you realize that if you're using a word processor, generally you can highlight what you want, right? And use the mouse to access a copy and paste function. But at the same time, you can use a shortcut like a Control X or Control C and then a Control V to paste, yes? And that gives flexibility to your user, all right? Consistency. Generally, we start with colors, right? If colors are consistent, right, then it's easier on the eyes. In the case where you need to actually communicate a message to the user, like what you're about to do is dangerous, maybe you can use a color that will communicate that. Okay. The other thing is that you want things to appear in consistent locations. So you don't want to have a text field at the top of the screen, and when the user put in something and presses a button, you regenerate the screen and the text field is now at the bottom. To tell them that, okay, an error was encountered, you entered the wrong data, please re-enter, and then the text screen moved to the left. Right? or the text field, sorry, moves to the left or moves to the right. You want to be consistent, right? If you're going to be sending error messages, right? Sometimes you can do a pop-up message, but if you're going to be doing pop-up messages, right? Don't switch from pop-up message to putting the message down on the bottom of a panel in a very subtle way that the user click something and it's not working, but yet still they didn't get a pop-up this time. That's inconsistent. And so the user might be searching, why the hell is this thing not working, you know? So you have to be consistent. Now, in general, the techniques that we have covered here are just enough to ensure that you can write a simple GUI using Java. Interestingly, many programmers don't write GUIs from scratch. They use some tools such as Eclipse or NetBeans, which can generate code for visual representations of code, right? You do get the flexibility of doing all kinds of things when you write it yourself. But today there are many tools to do it very, very effectively. And I'm sure you would be able to find some of those. And I think our tool that we suggested to you is Eclipse as one of the possible tools that you can use to write your Java code. And so there are some packages that you can use to do that pretty effectively in Eclipse. All right. And that concludes what we had to talk about today.